What's going on, everyone? Welcome back. Patrick here, and moving on to the next video, we're going to get some more practice in dealing with rationalizing expressions, and more specifically, we're going to rationalize the denominator in these 5 expressions here. So I'm going to erase 4 and 5. I'll bring them back later as the video progresses. So starting with number 1, we got root 5 minus 3 over root 10 minus 6 root 3. So first thing you want to check is, do any of the radicals simplify before rationalizing? So notice root 5 doesn't simplify, root 10 doesn't simplify, root 3 doesn't simplify. And so we can go ahead and rationalize from here. So we would multiply by the conjugate of that denominator. So we're just changing the sign in the middle, multiply the numerator and denominator. So it's like we're taking this whole thing, multiplying it by 1. And so from here, what would happen is I'm going to keep the 2 expressions in the numerator separated for now. We will have to FOIL them out just to see if it's going to simplify any further after. But for now, let's keep them separated. But in the denominator, because we're multiplying by the conjugate, we just have to multiply the ends. So root 10 times root 10 just gives us 10. And then we'll have minus 6 times 6 is 36. We multiply those because they're not under the radical. And then root 3 times root 3 would just give us 3, like that. And so now notice at this point that we got rid of the radical in the denominator. Right? It's just now we got to simplify. So what this would end up being is 10 minus 36 times 3. Now 36 times 3 would give us what? 108. So 10 minus 108 would give us negative 98. So this is basically going to be root 5 minus 3 times root 10 plus 6 root 3 all over negative 98. You could bring the negative up there if you want as well. Right? So if this is a multiple choice question, this is one format it may be in. But as I mentioned, you always want to expand because you never know if things will simplify further. So we've got to FOIL this out. So root 10 times root 5 would give us root 50. Then root 10 times negative 3 would give us minus 3 root 10. And then we would have 6 root 3 times root 5, which would give us 6 root 15. And then we'd have minus 3 times 6 root 3, which would give us minus 18 root 3, like that. And this, again, it's going to be all over negative 98. And then from here, notice none of the radicals simplify except for the root 50. So the root 50 we could break down into root 25 times root 2, which would give us 5 root 2. So this would be 5 root 2, but even with that, there are no like terms. All the radicals are different. So we got the root 2, root 10, root 15, root 3. So none of them can net out. Notice that we can't factor anything from the numerator. You look at the coefficients. Notice there's no common factor between 5, 3, 6, and 18. If it was just 3, 6, and 18, we could take out a 3, but this 5 here doesn't allow for that to happen. And so that there ends up just being the final simplified answer. There's nothing else we could do. We could take this negative, we could bring it up. So we could put like a negative in front here. Another way this might be shown is they may distribute this negative. So that would mean that basically all of the signs change. If we took this negative 1 distributed in the bracket, then all the signs change. So that's another way this solution can be shown. So just be careful the different formats that the solution can be in when you get something like this. But nevertheless, this does not simplify any further. All right, so that's the answer to number 1. And you could check your answer. You could take this, plug it into the calculator. You're going to get a certain decimal. Take this, plug it into the calculator, and the decimal should be the same. Right, moving on to number 2, we have root x plus root x minus y all over root x minus root x minus y. First thing we check, can we simplify anything? And we can't. We can't simplify any of the radicals, so we can get into rationalizing from here. And what's the conjugate of the denominator? Well, in this case, it's actually the numerator. Notice they're the same, it's just the sign is changed in between. So we would just multiply by that. Right, it's just a coincidence that these two are conjugates of each other. But nevertheless, the conjugate of the denominator is this over here. So we multiply the numerator and denominator by that conjugate. And so what would happen is we would end up with root x plus root x minus y multiplied by this. So both of them are the same, so we could actually just put a squared here. And that's going to be all over. These we just have to multiply the n. So this times that is x minus this times that is x minus y, but you got to be careful, make sure you put it in brackets like that, right? Because you're multiplying by that whole thing. And so from here, you could distribute the negative in. Notice that we would end up with x minus x plus y, so the x's actually net out to 0. Right, so we would end up with root x plus root x minus y squared all over y, like that. So you may see the solution be in this kind of format, but as I've mentioned before, you always want to check whether things will simplify further. So you actually want to take the time to FOIL out that numerator, because you never know what can happen. It's not guaranteed that it's going to simplify, but it may. So when we FOIL this out, root x times root x would give us x. Then we'll have root x times root x minus y. So that would be, it's like x times x minus y. So we could actually just put those both like that. And then we'll have root x times root x minus y, same thing as here. We're just multiplying the expressions under the radical by each other. And then we'll have root x minus y times root x minus y, which would just give us x minus y, like that. And then this here, what's it going to simplify to? Well, notice we'll have x plus x, so that would be 2x. And then this plus this, these are like terms, right? Notice the radical is the same, so this would end up being 2 root x times x minus y. You may also see this radical expanded like that. I'm just going to keep it factored there. And then we have that minus y at the end like that. Right? So this numerator, if you expand it, it ends up being this. Can't simplify this any further, so this would be all over y. Right? You can't factor anything out of the numerator. Nothing can cancel out. You can't cancel out with this y because these expressions don't have a y. You'd have to factor out a y first in order to cancel it, but these don't have a y lying around that you could just factor. Right? So this is another format that the answer could be in. So either this one or that one. I feel like this one's nicer, but you do, again, have to check whether you do have to expand the numerator, see if they could further simplify. In this case, it didn't simplify, but there are going to be cases where it will simplify. Moving on to number 3 now, we have 2 plus x over x minus root 2 minus x, like that. Notice here, nothing can simplify, no radicals can simplify, so we can get straight into rationalizing this. So we would multiply by the conjugate of the denominator, like that. So notice we just changed the sign in the middle. This sign doesn't change, right? This is a whole expression here. We have to keep that the same, keep this the same. Only the sign in the middle is changing. Okay, so we end up with that right there. So these two I'm going to keep separated for now. And then what happens here, x times x is x squared, then we'll have minus root 2 minus x times root 2 minus x gives us 2 minus x, like that. Right, and that has to be in brackets. And now we could distribute the negatives, so we'd have 2 plus x times x plus root 2 minus x all over x squared, negative negative turned to a positive x, and then we got the minus 2. Like that. So notice we have a quadratic now in the denominator. So we got rid of all the radicals, but we're not done simplifying, because notice that that quadratic, it actually factors into x plus 2 times x minus 1. Right? This factors into that. And now notice 2 plus x, x plus 2, those are the exact same factor. So those cancel out. And so what we would be left with, final answer for this, would be x plus root 2 minus x all over x minus 1. And then this here doesn't simplify further. There's nothing we could factor out in the numerator or anything like that. Right, so this here would be the final answer. Maybe another way it could be shown, you could split it up into 2 fractions. Like that. Both of those are the same thing. I feel like this one is nicer though, personally. Right, so just be careful with these, because sometimes you may get something like this, where you got to factor a quadratic or whatever polynomial function, and then things can cancel out, giving you a nicer final expression. And then finally, moving on to 4 and 5. These ones are going to be pretty unique, because we're going to be dealing with third roots over here. So you may or may not cover third roots in your class, but just wanted to add these in case you do. Now, when we're going to rationalize this third root here, what's going to happen is it's going to be the same process. We're going to have to multiply the numerator and denominator by the same thing. So it's like multiplying it by 1. But how do we get rid of this third root? Well, notice that we can't just multiply it by that same expression like that, because what's going to happen here? Well, the third root of x times the third root of x, this is like x to the power of 1 over 3 times x to the power of 1 over 3, right? The third root of something is like that, something to the power of 1 over 3. Notice when we add these, we would end up with x to the power of 2 over 3. That's still going to be a radical. This here is going to be like x squared to the power of 1 over 3, which would be the third root of x squared. Right? This times this would give you the third root of x squared. So the radical would still be there. It's not getting rid of it. Because it's the third root, what you want to do is multiply it again by the third root of x. Like that. Because then what's going to happen, if we multiply it again by the third root of x, and we add another x to the power of 1 over 3 over here, notice when we add these now, we would end up with x to the power of 3 over 3, which would be like x to the power of 1, which would just be x. So third root of x times the third root of x times the third root of x would give us just an x value. And now notice we would get rid of that radical in the denominator. Another way you may see this shown, instead of breaking it down into 2 expressions like this, you may just see, for example, when they rationalize, you could combine these. Third root of x times the third root of x, it's like the third root of x squared like we showed, so you can just say the third root of x squared over the third root of x squared. Right, you're just kind of combining these into one bracket. Another way this bracket could be shown would be x to the power of 2 over 3 times x to the power of 2 over 3. Like that. This, exact same thing. Or these two brackets, they're the exact same thing as these single brackets. So different ways this rationalization can be shown. Right, so I'm going to work from here. What's going to happen is we would end up with, let's keep those expressions separate. In the numerator, right, this times this, all over, well, we already know this times that is going to just give us x. Okay, so this is one way it could be shown, but you may also see this get distributed into the numerator. And just to show it, what I'm going to do first is I'm going to convert everything to rational exponents. And then I'm going to distribute, just so you can see it a little more clearly. If we start distributing with this and have all these radicals and numbers, it might get a little confusing. I feel like having the rational exponents, you can see it more clearly. So I didn't do anything yet. I just took the radicals, changed them to rational exponents. Then from here, if we expand, we would have 5x to the power of 2 over 3 minus x to the power of 2 over 3 times x to the power of 1 over 3. Well, we already know that that's just going to be x to the power of 1, which would just be x. So this would be an x over here, and this is going to be all over x. So, changing it back to radical form, this x to the power of 2 over 3 is like the third root of x squared. Then we'll have a minus x. That's going to be all over x. Okay, so this and this are the exact same thing. They're just in different formats. But either format, notice there's no more radicals in the denominator. So if you get like a third root, got to multiply it 3 times. All right, so that's how you do number 4. Now number 5, this one's going to be interesting. Notice that we have this expression xy over nz squared to the power of 1 over 3, which is like another way this could have been written is the third root of xy over nz squared, just as a heads up. Then we're multiplying by 2 to the power of 2 over 3. Now, before rationalizing this, what I'm actually going to do is I'm going to combine these into one term. Notice you could do that because if I rewrite this, that's going to be to the power of 1 over 3. This 2 to the power of 2 over 3, we can rewrite as 2 to the power of 2 to the power of 1 over 3. We can split up that rational exponent. What's 2 to the power of 2? 4. So we got 4 to the power of 1 over 3, or the third root of 4. So this and this, they're the exact same thing. And the reason why we want to do that is because now notice that these two terms in the brackets have the same exponent, and they're multiplying. And if you remember your exponent rules, basically, if I got a to the power of x times b to the power of x, well, that's the same as ab to the power of x. Usually it's shown the other way, like if you have something like this, you could split it up like that. But in this case, we're doing the opposite. We're in this format. The a is like this whole bracket. The b is like this whole bracket. And we're going to put them into one. So we're not working with two separate terms, especially with like third roots and stuff. It could get a little complex. Just much easier to combine them into one. So this 4 multiplied by this is like 4 over 1. So we would end up with 4xy all over, this times 1 is just 9. z squared. And that's going to be to the power of 1 over 3. So I haven't rationalized anything yet. I've just simplified it into one term. But from here, we can rationalize. So a couple of ways to do this. What we can do, remember this is like the third root of 4xy over 9z squared. And we could rewrite this. We could take that third root and distribute it to the numerator and denominator, which is what I'm going to do for now because we got to get rid of this radical in the denominator here, basically. And so if we follow the exact same steps that we did in number 4, notice we got the third root of an expression. One thing we can do is multiply it by the third root of that expression over the third root of that expression. But because it's a third root, we got to multiply it again, as we did before. Okay, so that's one way to go about it. I'm going to show you something else, though, in a sec. And so what would happen is when you multiply these, you would end up with 9z squared in the denominator. And then you'd have to multiply the 4xy times the 9z squared times the 9z squared, like that. And then simplify from there, whatever that would end up being. But a more simple way to do this, it's just tougher to see, is if you notice the 9z squared, we can actually rewrite that as 3z to the power of 2. Okay, 3z to the power of 2 is equal to 3 to the power of 2z to the power of 2, which would be 9z to the power of 2. So I just took this, rewrote it like this, and the reason this helps is because now to rationalize this, we actually only have to multiply it by the third root of 3z. Because this over here, this whole expression, it's like 3z to the power of 2 to the power of 1 over 3, which is like 3z to the power of 2 over 3. So we only have to multiply by 3z to the power of 1 over 3. Notice when we add these would end up being just 3z to the power of 1, which would just be 3z. And that would get rid of that radical. Okay, it's a little tougher to see. You could do it the other way that I had when we multiplied it twice by the third root of 9z squared. It's just there's going to be more simplification later. Here, there's going to be a lot less, right? Because we're only multiplying this and this. Right? So again, a little tougher to see, but basically, what would happen here when we do this is we would end up with this times this. Notice they're both third roots, so we can multiply what's under the third roots. So that would be 12xyz. And as I mentioned, that's going to be all over 3z, like that. Okay, another way to see this, the third root of 9z squared, if we take this and multiply by the third root of 3z, this would end up being the third root of 27z to the power of 3, like that. And notice that when we simplify this, what would happen, third root of 27 would be 3, third root of z to the power of 3 would just be z. So we'd end up with that right there. Right, so whether you multiply this by that or this by that, you end up with 3z. Now, let's go back to the other way. If from here, let's say you rationalized it by multiplying by that third root of 9z squared over the third root of 9z squared. And you got to multiply 3 times, right? 1, 2, 3. Okay, what would happen here now? This times this times this would obviously give us 9z squared. But then we got to multiply the 4xy times this times that. So notice 9 times 9 would give us 81. And then 81 times 4 would give us 324. So we'd have the third root of 324 x, y, z to the power of 4. And so what would have to happen from here is we would have to simplify this whole numerator. Okay, notice that, I'll just do it down here. The third root, for example, of 324, you'd have to break this down into a number that's rootable by 3, so 27 works. Okay, 27 times 12 gives us 324. And then what's the third root of 27? That's 3. And then we'd end up with the third root of 12. So continuing this over here, what we would have in the numerator, we would end up with 3 times the third root of 12. That's what the third root of 324 would simplify to. Then the third root of x, third root of y, that doesn't simplify, so we could keep those. But then the third root of z to the 4, we can break that down as the third root of z to the power of 3 times z to the power of 1, which would be the third root of z to the power of 3 times the third root of z, which would end up being third root of z to the power of 3 is z, and then we'd have the third root of z. Okay, so the third root of z to the 4 simplifies to this, which would be z third root of z. Okay, and then this is going to be all over 9z squared. And then notice the 3 and the 9 simplify, and then the z and that z simplify. And then we could recombine these because we have the third root of z times the third root of 12xy, so that would end up being the third root of 12xyz all over 3z, which is exactly what we got here. Right, so a lot more work going from here and then simplifying that to this, versus just recognizing how we could rewrite the 9z squared as 3z to the power 2. And then when we rationalize, we only have to multiply it by that third root of z. And so we end up getting right here right away. So it's like we kind of noticed the simpler way to do it at the beginning, and then it saved us simplification at the end. But if you do it the long way, you'll get the same answer. It's just there's going to be a lot more simplifying to do at the end.